Welcome to this episode of Space. Today we're talking about nanosatellites, tiny cubes full of nanotechnologies, which are going to be more and more important in the future of space exploration, from Mars missions to the surveillance of asteroids, which could potentially be dangerous for our planet. At the Mektory Space Centre in Tallinn, Estonia, students are preparing to launch their first nanosatellite.
CubeSats, or nanosatellites, are tiny satellites that open up a whole world of possibilities for those who want to explore space. Their potential is being seized upon by everyone, from big space agencies to small groups of students, like here at the Mektory Space Centre at Tallinn's University of Technology.
I would have never thought that I can build a satellite in my life, because I've always thought that only NASA is building satellites. But no, I can do it in my own university also.
We are all coming from different backgrounds in this project, and as a team, we work as a team, and all of us put in so much efforts.
The Mektory Nanosatellite programme is an international university initiative being worked on by students and professors in association with space and technology industries. Its goal is to prepare students for working in the space industry. They're currently working on their first space mission.
We are developing one unit cube satellite for remote sensing mission, which means that the satellite has to take pictures of Earth.
This kind of satellite can fit in the palm of your hand and weighs between 1 and 10 kilograms. It's low cost because it's largely based on existing electronic components. The launch of the student-made nanosatellite is likely to take 2 more years of work.
From the project plan until the completion of the satellite takes 3 years, of which 80% of the time is usually meetings and design behind the computer. And actually, when you start to produce this final piece that is going to fly in space, then the machines puts it together in a certain environment and place the components within 1 minute.
CubeSats deliver into orbit a high concentration of nanotechnologies that you can even build using a 3D printer, as they do here in Tallinn. CubeSats have also caught the attention of the European Space Agency, which wants to send these tiny satellites deeper into the solar system. Roger Walker coordinates ESA's CubeSat efforts at the agency's technical centre in the Netherlands.
Computers have themselves been shrinking over time, going from a computer that would be the size of a room to something which you now see on your mobile phone. In the space sector, we see that satellite functions have been shrinking from something the size of a washing machine to now something the size of a CubeSat, basically a satellite in a shoebox.
In addition to being valuable educational tools, CubeSats are fit for a wide range of applications. For instance, as an affordable test for in-orbit technologies, or to carry out observations and measurements in space.
There is a complete satellite functionality inside this box. So you have the possibility to generate power with solar panels, distribute the power internally, communicate with the ground station on Earth, and also to run experiments and transmit the data back down to ground again.
Here at the ESA's radio testing facility, a CubeSat called Carmen is being examined. This year, it will be used to test re-entry technologies and heat shield materials. But the future for these tiny satellites is even bigger. An ESA-NASA mission to impact and redirect an asteroid is due to start in 2020.
We're studying CubeSats for scientific and exploration purposes in deep space. And one of those missions would be piggybacking on the asteroid impact mission. Those CubeSats would be taking observations of the asteroid before and after a NASA spacecraft comes in to impact the asteroid itself.
These tiny spacecraft can have multiple applications as the process of miniaturization is unstoppable. CubeSat developments can go from space debris removal to commercial telecom services. In the coming years, they'll also be embedded in exploration missions to the Moon and Mars. The cheaper costs of their production and launch are provoking more and more interest in CubeSats within the space industry.
The younger generation now growing up, they will be the ones to figure out what to do with this technology in the best way, and we will probably see things which we never saw or even thought of before.
I just can't wait for it to happen, for our CubeSat to be launched, and it will be a great achievement for every one of us.
We are making more people capable of doing things for space, and also preparing them for the bigger missions.
I also hope that our university will build a bigger satellite. And why not to bring one of our students to the moon one day? Why not?
This year on Space, we'll be following a mission called ExoMars. It's the first to look for direct signs of life on the red planet. The first of 2 missions is imminent. We have exclusive access to the team. This is Destination Mars.
I'm Jorge Vago. I'm one of the ExoMars project scientists at the European Space Agency. Mars is a cold, frigid desert with a very thin atmosphere that gets bathed in cosmic radiation and intense UV light. It's not a place you want to be in. In March, a Russian Proton rocket is going to send our first spacecraft to Mars. We want to solve the mystery of methane on Mars. And the second mission, which will go a few years from now, has a rover and an instrumented surface platform as well. We really are going for traces of life with the ExoMars program. Once the rover is on Mars, it will encounter fine dust, very challenging for locomotion, and rocks. So dust, fine dust, is not our friend in this mission. It is technically hard, it is scientifically very ambitious, and also programmatically, it is not often that 2 agencies get together to do missions on another planet.
You can find the entire space series on our website, euronews.com/space. Thanks for following us. Goodbye.
Arrivederci.